We all know what a vector is. It's a physical quantity with magnitude and direction. The concept of a unit vector is important, but it is not new. Unit vector, as the name implies, has a magnitude of 1. You have already seen unit vectors, I, j, and k, associated with x, y, and z axes. For example, vector I is a vector with a magnitude of 1 along the x direction. Please keep in mind, when I say the magnitude is 1, it means 1 in whatever units we are dealing with. It may be 1 meter or 1 millimeter or 1 inch or may stand for 1 Newton. Typically, we put a hat on a vector to indicate that as a unit vector, and I will do this consistently in our discussion. It's a good habit, so please practice. Notice that hat on I, j, and k. All right, I have here a vector f is equal to 3. This means the vector f is along the x direction and it is 3 units long as shown here. Now we want to learn about other unit vectors that are not along x or y or z axis but along any arbitrary direction. All of us know a simple truth. If you divide a number by itself, you get 1. It's like saying if I have 10 oranges and if I divide it by 10, I get 1 orange. Applying the same logic, if we take a vector and divide by its magnitude, we will get a unit vector. Mathematically, I can write this expression as shown here. Here I have indicated the unit vector as E hat. Some texts use lambda for the unit vector. We will use E hat in our notations. Let's expand this a bit more. Let's say f is a vector in 3D space and it is equal to 286i plus 424j plus 549k. The magnitude of this vector can be found by squaring each term, summing them up, and finding the square root. This value happens to be 750. So we can find the unit vector which lies along the direction of this force by dividing the vector by its magnitude 750 as shown here. You can verify that magnitude of this unit vector is 1. Why are we doing all this? Because often it is easier to determine a unit vector using the available coordinate information. And if you know the unit vector and the magnitude of the force, then we can write an expression for force itself. This is very useful. Let's solve a problem using this approach in the next video.